In object diagrams, what happens? We have objects and how these objects are interacting with each other, we are talking about it. If we are talking about interaction, then the diagram is something like sequence diagram. If we are talking about what message is being passed, we call it a collaboration diagram. Operations, if we are talking about, we call it deployment diagrams. So these objects are represented like this with object ID, class name, and attribute with values. We have the objects which can be having relation with other objects, which can be shown in a diagram with this links to it. So after that, we are coming to package diagrams. What happens in package diagrams? Whenever we have multiple classes and we want to keep them in a separate groups, then we can have packages. So a package, you would have heard about your in your programming that there are certain this package, different packages are available for working, right? So it is a group of your classes, those classes which you can use. Okay, how to represent such things? Sometimes when it is your system is going to be complex, means you have many number of classes and it may be difficult to maintain all of them in all together, then you can group them separately and that will be called as packages. So it will be represented by a rectangle with a small tab, right? This is the way how you represent a package. So this package may have may interact with notification kind of package or the other packages whatever needed. Other package diagrams can also be there. These are the package diagrams. These packages are there: mailing list, manager, student, and academic employees. Another example can be something like this, where one package is having another sub package. These packages are also interacting, you can see. So this is a simple thing about the package diagram, that how you can represent your packages, how you can group your classes and keep them in packages. If we talk about interaction diagram, now we are coming towards our sequence diagram, where actually we try to describe how objects are interacting with each other. So here in sequence diagram, we show these things, the events that what happened, and we also show the time progress. Okay, so according to the time, we show that what are the events that happened, which object was able to send some message to another object, and because of that particular message, what happened. Okay. Now here you can see objects involved are listed left to right. Left to right means in a horizontal fashion, and the time will move in the vertical downward fashion. Now messages are sent left to right between the objects. It's okay. So you see this example. These are the objects you can see, and this is one actor. These objects are the part of your system. However, this is an actor who will be interacting with the system, right? So here what happens? He interacts. He sends a message. He gives some number. It was enter a number. So what happens? This object particular understands it and accordingly takes some action. Here you can see that time is progressing in the downward direction. So by the time it understands that given this number, we have to find something. So it executes a find method for the item object. So here this request comes. This object, what it did, it tries to understand what has happened, and accordingly if it needs to access some information from other object like a stock item, so it sends a request to get quantity to a stock item. So time progresses, you can see this is the progress of time progresses, and then the result comes, and again after some time from here it sends the result back, and then after some processing the result is displayed back to the user. Here you can understand these are the solid lines. These solid lines are representing that we are calling a function of a particular object. We are requesting something, you can understand. So we are requesting here. These dashed lines, they are showing that we are returning something. Okay. Now here are two things, that this is activation, that means this actor was active during this time period, and this thing you can say it will be called as lifeline, that it will remain live on according to the time. It's okay. So this was something about your sequence diagram. What you do, you have your objects and some external user who will try to access during its activation period. He calls for some methods of a particular object, and after processing some results are displayed. In between, this object may call another object for some information as well. So whatever events are here going on, we show those all the events in a sequence diagram with a timeline. Okay. In a sequence diagram, if you want to show that what happens, this is the object, it is there working, doing something, and after some time you want to destroy this object. So this may also be shown that this was the operation. You can create an object, some operation was performed, and after some time you get you no longer need this another object, then you can issue a destroy method, destroy call. So this object will be destroyed. So such thing, if you want to represent in your diagrams, this is the way you can represent it. Now another example here you can see. Suppose what is happening here, the line is slanted here, you can see. Okay, slanted means it starts from the first object, but it takes some time to reach this particular object. So this time also you can show it here in the diagram. If the straight line was there, it means that at a time it will reach that particular object, but sometimes it may not happen. These servers, different objects may be on a different location. In that case, you may take some time. Since it is taking some time, you should show it by a slanted arrow, slanted lines. Here this is a system for dialing phone. So this is the telephone. User hooks off the receiver, dial tone comes, dials the number, and at the time here you send a ringing tone for this another user, and you send a ring back to the caller. Sometimes after that this user hooks off the receiver, then you connect both of them, means the phone service, phone object, whatever they are, then they can continue talking. So here actually we have to understand that if there is a kind of a little delay in the delivery of your message or whatever, then you can show it with a slanted line. Okay. Now this is another example of your sequence diagram. So here also you can see the same thing. What is happening? These are the two objects, and there are some other actors as well. Okay, so what is happening here? This is a actor, which is a sensor, which will produce some information. Okay, so having this information, an event will be generated, which will be displayed on the control panel. User will be it will be displayed to the user, and that's it. Something will be done, right? After that, after some time, if nothing happens, a ring may come to the acoustic transmitter, and it may be, I should say, it can be approved from here that yes, it can be ring. The signal can be sent to the monitoring service that okay, this thing has happened. Means whatever you want to show according to your need of your system, all those possibilities are here. Not only the objects, you can have some actors as well. That is the thing. Till now, if you have any question. Here is another example of hotel reservation. Some of the objects are there, you can see. And what is happening, this is the window interface from where a method will be initiated, which will be make reservation, and it will come to another object where it will start reservation. It will make it will call another reservation to the hotels, different hotels. If the first hotel, what is happening, it will try to find out if we have the available rooms. If the room is available, then it will reserve the room, and also make a notification and send the notification to the user. And once the reservation is done, it can be destroyed also. If you want to show this information, you can show something like this. Okay, so this was all about your sequence diagram. I believe now we can talk something about collaboration diagram. Before that, if you have any confusion, anything you want to ask about the sequence diagram. Do you want to ask something? So what happens in collaboration diagram is, here you show the similar thing as we saw in the sequence diagram, that the events are taking place, but you don't have a timeline. You don't show it in a vertical sequence. Okay, that first this event occurred. Means here also you are numbering the events, so it shows that which event occurred first, but you don't have that vertical sequence. That is the thing. Objects are linked together, and the messages are shown with an arrow, and the messages are written there with numbers. So what is happening here, you can see the similar example. There are two objects of user class, one object of telephone, and what is happening, first of all, these user is contacting this telephone with somehow accessing. First of all, hook off, then dial tone comes, ring is there. If the receiver is hook off by another user, then what happens, it is both them are connected, and once they are connected, they can exchange the message directly. So such kind of things are there in collaboration diagram, that the objects can interact with each other. Any confusion till now? I believe now we can go for activity diagram. Okay. So in activity diagram, what happens? Whatever the activities are involved in your process, they are shown here. What is the current state? What are the swim lanes? Swim lanes means which object is responsible for what activity. Branch, transition the branch indicated by a diamond. Fork, parallel activities if you want to go for, and a start and end symbol. So you see, this is an activity diagram. This is for an ordering system. Now what happens, from here you are starting. The state is begin order. Here it is a rhombus. The rhombus says it is a decision statement. Here you try to decide something and go for add item. This is a state where you will be doing something. Another, again you are deciding something here. Maybe you are deciding whether you have to repeat it or not. And then you go for the calculating total, whatever this thing. So this is an activity diagram. You should not confuse it with flowchart. Flowchart is different. Activity diagram is different. Okay. Is there any confusion here? Okay. So here whatever we are showing in this ovals, they are your states, that what is going on here. It is different from your normal flowchart. Okay. In normal flowcharts, so what is happening? You will have rectangles, you will have parallelograms, definitely rhombus are also there, and start and end are not this symbol, they can be in a oval. Okay, so those are the differences there. Okay, so this is another activity diagram. Here you can see where you can see that these are the objects: customer, ATM machine, banks, and what are these processing which will be done by these objects. We are calling it swim lane. It shows that these are the part of processing which will be done by these objects. Okay, so what happens, it will start from here. You will insert the card, you will have to enter the PIN, and it will go to the bank. Then bank will do something, it will find out whether it is valid or not, accordingly do the necessary things, and again it comes here. This is a fork command. Fork means you are from here two processes are going to execute. So one you can see it is in this direction, debit the account, and one is take money from the slot. So two actions will take place from here, debited from the account, as well as also money will be coming out to be delivered, right? And once these both of them are completed, both are joining here, you can see, for and they are moving further to find out whether the balance what is we have to show the balance or not. And then whatever according to normal ATM thing that you do. So here what we are trying to understand is multiple objects are there. If we want to have one scenario, one example of the events that are going to take place, what we do is we involve all the objects which are involved here, and accordingly we keep those processing part in their lane to represent that this is the part which was done by this object. So for this object there should be certain methods which should support this kind of operation. Okay, so this is something that you have to understand in activity diagram. The next thing is a state transition diagram that we can go for. Before going there, do you have any confusion, anything you want to ask? In a state transition diagram, we understand that it is similar to a DFA, where what happens, we have states. These states are there in a rounded rectangle, and there are transition from one state to another, and this transition is shown as arrow. Whatever the events are there, which that event which triggers this transition, that event is kept beside the arrow, written beside the arrow. There are final states as well, initial and final states, which are displayed. Similar to as it was in activity diagram, similar means full black or with a concentric circle out of the full black, right? So the set of properties and values, okay, describing the object. Okay, we are talking about these things which will be there in the state. You will have the name of the state, the activities when you are in this state, what are the things being done, and what are the entry and exit actions. Also these actions on a particular event, if the event occur, what these actions need to be taken. States are represented like this. You will have the name and entry exit condition, event based actions. Transitions, if at all being represented by an arrow, you will name the event which is triggering the transition, and what actions are being taken place, right? Mode, okay, simple means this is on and off kind of a state, two states only. If it was off, you triggered it, and it was on. When it was on, you did the same thing, it was off. So such kind of things may also be possible. But if in your system there is something like that, you should represent it with such a state diagrams. Here again you can see another example of pen verification. What is happening with the start, we come to here, we try to press some keys, and we remain here on these events. On another event for something, whatever saved or whatever event, according to that event we go to another object. There also with some event we are keeping doing something and remain in the same state. On another event which is submit, either from this object or from this object, we are coming to another object, another state. Okay, in another state we are validating, we validate, and on if it is validated, if it is valid, we go to a final state, we start the transaction. If it is invalid, we come to rejecting the state, we give an option to retry, or we can cancel or quit also. Okay, so having this example, let us see some more things. If you want to store some local variables, you can do it. In a state, you can show that you have a variable n. On a particular event, you want to increase or decrease it, perform some operation, you can show it here in the state diagram. Okay, now the next thing will be your component diagram. Before that, let me ask you if you have any confusion.